This is another variation of the common river flow problem, where you have to find the shortest possible path instead of the shortest possible time. So Piyush will take us through the question.
Okay, there can be also cases like the path line must be some specific. Then you can also use like the x coordinate and y coordinate you have can find. But in this question, like it is given shortest possible path. This is a special case. So we will first write the first basic equation that we know. Okay, we know that VB is equal to what? VBR cos theta plus VR I cap plus VBR sin theta j cap. This is a simple equation that we have write like 2-3 times.
That's the variation of what we showed you in theory.
VBR and VR means the same thing that we like usually.
VB is the velocity with respect to someone on the river bank. And the velocity VBR is the velocity of the boat in still water, and VR is the velocity of the river.
Yes. So like if this is bank A and this is bank B, okay, and you got to reach from here to there, the shortest possible path can be what? When the line perpendicular to this.
Yeah.
So that means that, for example, if VB is equal to VBR plus VR, this is the VB vector, right? But we want this VB vector to be in this direction, because this is the shortest possible path. Yes. So what we want basically is that the x component of velocity must be equal to 0, because the velocity should be perpendicular, right? So only VBR sin theta should be there, like VBR cos theta plus VR should be equal to 0.
Yeah.
Okay. So
there must be no horizontal component.
Yes. तो VBR की वैल्यू हमको दे के रखी है 5 किलोमीटर पर आवर. Okay. So 5 cos theta plus VR, जिसके वैल्यू हमको नहीं पता, VR is equal to 0. Okay, this is the first equation. Now second thing is that हमें देके रखा है कि VB हमें टाइम देके रखा है कितने टाइम में वो पहुंच सकता है. ओके, सो टाइम बेसिकली होगा क्या? ये डिस्टेंस अगर d है, टाइम इज सिंपली इक्वल टू d अपॉन Vy इंटू टी, बिकॉज Vy कांस्टेंट है. तो टाइम हो जाएगा 15 मिनट्स, दैट मीन्स 1/4 आवर. ओके, we will convert it into hours because like the velocity is given in kilometers per hour.
Be careful of the units.
Yes, that's a very important thing. Silly mistakes. So VBR, that is equal to 5 sin theta, d upon 5 sin theta is equal to 1/4. Okay, and d is equal to what? 1 kilometer. The width of the river is 1 kilometer, so we have d is equal to 1/4 is equal to 1 upon 5 sin theta. So simply we have the value of sin theta, that the value of sin theta is equal to 4/5. Sin theta is equal to 4/5, so you can calculate.
Sin theta equal to 1/20.
Yes?
Sin theta is equal to 1/20, right? Not 4/5. 4/5, sorry.
Okay, so sin theta is equal to what? We have, this is 1, sorry. I will like correction for you. So this is 1, okay. So because the width of the river is 1 kilometer, so sin theta is equal to 4/5. So we know that cos theta is equal to under root of 1 minus sin squared theta. We will calculate it and we will find that the cos theta is equal to 3/5. It's very simple. So what we will do is we will put the value of cos theta in there to find the value of VR. Okay.
Yeah, in the first equation. Yeah.
Yes. So we will find that VR is equal to minus 5 cos theta equal to minus 5 into 3/5. That is equal to minus 3. Now we're getting the minus sign because like we know that sin theta is equal to 4/5. Now cos theta can be plus minus 3/5 in this case. So now if the angle is this, like this is a theta angle, then only this case is possible because we are in this direction. We can assume both the cases. If this is the case, then VR will be in this direction, and if this is the case, if this is VBR, then this will be the case. VR will be in this direction, but it doesn't matter because the question is not asking for the direction, just the magnitude, which is equal to 3. So we have answer as 3.
Now the problem that we have here employs two concepts basically: the notion of projectile motion, which was discussed in theory, as well as the certain conditions which need to exist for particles to collide with each other, and the distances they travel before colliding. So, Piyush, please take us through this problem.
Okay, so this is a very good problem, and it is two guns situated on the top of a hill of height 10 meter, fire one shot each with the same speed of 5√3 meter per second, with some interval of time in between.
Okay, so one gun fires first, then after a little while,
after some time the other gun fires.
Okay.
One gun fires horizontally and the other fires upwards at an angle of 60 degrees with the horizontal.
Alright.
Okay, so the shots collide in the air at point P. So we have to find the time interval between the firings and the coordinates of point P. And we have to take the origin of the coordinate system as the foot of the hill, and trajectories is as
so both the guns will be treated as 1 point.
Yes, both the guns will be released from the same point, but there will be a certain time lap between the two guns. And the first gun will leave at an angle of 60 degree, and the second gun will be like horizontal, in the horizontal direction. So let's write the equations for both the guns. Let us assume that the time lap between the two gun shots fired is t0. Okay, so we have
t0 is the time interval.
Yes, t0 is the time interval. So if we assume that the second gun is in the air for time t, okay, when the two particles collide, that means the first particle will be in the air for time t plus t0.
Correct.
And the second will be in air for time t. Okay, so what we will do is we will write the equations like RA and RB vector for both of them. Okay, RA is the shot which is fired first. Okay.
Alright.
Okay, so RA vector is equal to,
these are the position vectors.
yes, x I cap plus y j cap. Okay, so I have to write the x coordinate. X coordinate is initially it is equal to 0. So finally it will be equal to 5√3 into cos 60 degree into t. Okay,
A
because
is the one which is fired at 60 degrees.
Yes, A is the one which is fired at 60 degrees and which is fired first. Okay, so plus, now we would have to add the vertical component. Now since delta y is equal to that, we write that v sin theta t minus half gt square, and y0 is equal to 10, so we will write it as 10 plus 5√3 sin 60 degree into t minus half gt square. G is equal to 10, that is we have to given that we have to take it as 10, so
you're using the familiar equations of
motion.
And we are adding 10 because the height of the hill is 10 meters.
Yes, at t equal to 0 the y coordinate is 10, so delta y is equal to that, so we have to add y0.
And we are using that familiar formula ut s equal to ut plus half at square.
Yes, that thing.
Correct.
Yes.
Okay, carry on.
And for RB, now here t is equal to t plus t0.
Right.
Okay, so we will just write this equation again, and we will like write this 5√3 by 2 into t plus t0 I cap plus 10 plus 15 by 2 t plus t0 minus 5 t plus t0 का whole square, and this is whole in the j cap.
Yeah.
Okay, so similarly we write the
clarification. We play in the first line we had t as an arbitrary value of time, but we are now replacing it by t plus t0 because this one was launched first.
Yes.
And we are taking the time t plus t0 as from the time t equal to 0 when they collide. So
yes.
t plus t0 is when they collide.
And the ball B, which is fired later, will be in the air for time t seconds only. So yes, so we will write the equation clearly for directly for it by taking time as t here.
Okay.
So now for RB, we have here the angle with the horizontal is 0. Okay. Right. So the equation will be 5√3 t I cap plus 10 minus half into gt square, so 10 into t square j cap. I write it like this because the vertical component of the initial velocity is equal to 0. So the term u sin theta t will not be there. Okay. So now after some time the particles collide. Now you must know when two particles collide, what does it mean? It means that the position vector of the two particles must be equal.
Must be exactly the same.
Yeah, must be exactly the same.
Of a collision.
Yes, so that means that RA is equal to RB, right? Or it simply means that XA is equal to XB and YA is equal to YB. And XA and XB are that like the X components of the displacement. Okay, so we have two equations, and the two equations are 5 root 3 by 2 into t plus t naught must be equal to 5 root 3 t, right?
Correct.
And
just equating the x components.
Yes, and if you equate the y components, like 10 and 10 will cut out, so like we can omit this, and we will have 15 by 2 into t plus t naught minus 5 into t plus t naught ka whole square, that is simply equal to what? Minus 5t square. Okay, these are the two equations. So I give it as a homework for you, like you have to solve these two equations. So I am going to tell you what is the value of t and t naught. Here we will have the value of t and t naught as t is equal to 2 seconds and t naught is equal to 1 second. 1 second. Okay, so that means that the first part of the question is the time interval between the firing, that is simply equal to 1 second, because t naught is a time lag between the two firings. So this is the answer of the first part.
T naught is the time interval.
Yes. Now what in the second part I have to do? Second part I have to find the coordinates of point P. Okay, so what I know both t and t naught. So what I will do is that I will put the value of t and t naught in either of RA and RB and find the position vector simply.
So that will be the position vector of the point P.
That is a simple thing. I also leave that thing to you, because it's like we have the value of t as 2 seconds. Just put it in RB. You will have 10 root 3 I cap plus 10 minus 5 into 2 square j cap. So that is a simple thing. You don't need to worry about that. It's a simple question. Okay. So the answer that we have is the coordinates are 5 root 3 comma 5. The coordinates of point P are 5 root 3 comma 5. Okay, you can easily find them by putting the value of t and t naught.
5 root 3 I cap plus 5 j.
Yes,
Be the position vector of the point P.
Okay.